Okay, so here we shall explain some properties of determinants with some examples. So the third property, the property 3, is that if any two rows or any two columns of a determinant are identical, it means all the corresponding elements are same, then the value of the determinant is 0. So if any two rows or any two columns, if any two rows or any two columns of a determinant, if a determinant are identical, it means what? That if all the corresponding elements are the same, if all the corresponding elements, if all the corresponding elements are same, all the corresponding elements are same, then the value of the determinant is 0. And the value of the determinant is 0. The value of the determinant is 0. Suppose, for example, it has been asked to evaluate the determinant delta, which is equal to 3, 2, 3, 2, 2, 3, and 3, 2, 3. So here we can see that R1 and R3 are identical. Here the rows, first row and third row are the same. Means the here R1 and R3 are identical. So let's see if the value of the determinant will come 0 or not. So if we expand this determinant along the first row, then it will be 3 into 2, 3 is 6 minus 6, then minus 2 into this will be 6 minus 9, then plus 3 into 2 2s are 4 minus 6. So this will be 3 into 0, that is 0, minus 2 into minus 3, then plus 3 into minus 2. So this will be 2 3 is 6 minus 6, that is equal to 0. So hence we see that since the two rows are identical, the corresponding elements are same. Therefore, the value of the determinant will come 0. Hence, the property 3 is verified here. Okay. Then the property 4 is that if each element of a row or a column of a determinant is multiplied by a constant k, then the value of the determinant also gets multiplied by that constant k. So if each element of a row, if each element of a row or a column, each element of a row or a column of a determinant is multiplied by a constant k, then its value is also multiplied by k. Then its value is also multiplied by k. Multiplied by that constant k. So then so suppose, for example, it is asked to evaluate the determinant uh, delta, which is equal to 102, 18, 36, then 1, 3, 4, 17, 3, 6. So we have to find the determinant of this So from here we can see that the row 1 and row 3 are proportional actually. It means that 102 I can write this is 17 into 6, 18 is 3 into 6, and 36 is 6 into 6. 1, 3, 4, and 17, 3, 6. So from the first row, I can take 6 as common. So this will be 6 into 17, 3, 6, 1, 3, 4, and then 17, 3, 6. So here we see that since first row and third row are equal, so the value of this determinant will be 0. So therefore, the answer will be 6 into 0, that is equal to 0. Now, um, simply the rule is that if we have a determinant that is delta equal to, suppose A1, B1, C1, and A2, B2, C2, and A3, B3, C3, and if delta 1 is that all the elements in the first row is multiplied by the constant k, then if delta 1 that is equal to the determinant ka1 kb2 then kc3 kc sorry a ka1 kb1 kc1 and a2 b2 c2 then a3 b3 c3, then that will be equal to k into the determinant of a1 b1 c1 a2 b2 c2 a3 b3 c3. So this will be equal to k into delta. So since the first row has been multiplied by the constant k, so delta 1 will be equal to k into delta. So then okay. So hope you have understood these two properties. So thank you.